Alright guys, in this quick walkthrough I'm going to cover unconformities. Remember there are three types of unconformities. There are disconformities, nonconformities, and angular unconformities. All three are a little bit different. Disconformities, you're going to look for erosion. That's how you're going to be able to tell a disconformity. And an angular unconformity, you're going to look for non-parallel. And for a nonconformity, you're going to look where you have igneous contact with sedimentary. So let's go ahead and take a look. One key thing to note is that we have our rock symbols here. All of these guys here are sedimentary, and these guys here are igneous. That's going to be our clue for nonconformities. So as the directions say, it says for each of the following diagrams, locate and label all unconformities by drawing a line through it and marking with a D for dis, N for non, and A for angular. Let's go ahead and do that real quick. So here we go. We have this diagram right here. We have a clear erosion path right here. How do I know it's erosion? It's erosion because these strata typically get deposited horizontal and flat, and these dips and divots in here show us that there was erosion, and there's our disconformity right there. Okay, next diagram to the right. We have a couple of disconformities towards the bottom. Here's one above the conglomerate, and here's one above the sandstone. Those are each a disconformity. And we also have a nonconformity right here where the igneous is meeting the sedimentary. And from what we can tell, this is a lava flow. It's not an intrusion unless if there was a layer above that got eroded away. But from the evidence that we have, this is a lava flow because it was only changed on the bottom. The one below that, we have another nonconformity. It's right here. It's where the igneous rocks touch the shale. And that again would be a lava flow. You could tell it's a lava flow because there was no metamorphic contact on the top, indicating it to be an intrusion. And then above that we have shale. This is a disconformity to mark the erosion. And then we have another lava flow with another nonconformity right there. And I'll put LF for nonconformity. I'm sorry, for lava flow. Alright, the one below that, we have an angular unconformity here because we had folding happen. The layers originally got deposited horizontal, then something happened to cause them to fold. And then above that we have a nonconformity boundary. This again is a nonconformity that is a lava flow. A lava flow. How do I know it's a lava flow? Because when the granite came in, or when the magma came in, before it hardened into granite, it only changed the layer below. It did not change the layer above. That would indicate that it's a lava flow and not an intrusion. Cruise over here. Now we have a couple of different things going on. Here we have one that shows two. This guy is an angular and a disconformity. The angular because of the non-parallel strata, and the disconformity because of the erosion waves. We also have this big intrusion from this basalt volcano here. This is a non-conformity, and it is certainly an intrusion. It's an intrusion because it went through all the other layers to get to the surface, and it also has metamorphic contact on both sides to show that it was an intrusion. We have another one here. Here's an angular unconformity. Again, non-parallel strata below with parallel above it. And then we also have a nonconformity here, which is also an intrusion. You can tell it's an intrusion because it was changed on both the top and the bottom. All right, we have a couple more to do here. Here's this guy. We have a disconformity here, another disconformity, another disconformity, and lastly, this guy is also a disconformity because of the deposition on top of it. So everything that's in this diagram is a disconformity. Taking a look at the one next to it, we have another disconformity right here. Taking a look at the one below that, we have another disconformity here, little disconformity here, and it's also angular. So here's a dis, here's an angular and a dis. You can tell it's an angular because of the folded strata, and you can tell that it's a disconformity because of the erosion patterns that you see. Next. We have an angular unconformity here with all the folded strata below. We have a disconformity right here, another disconformity right here, and what we also have, in case you missed it, is this guy here. This is a nonconformity with the basalt, and it is a lava flow because it was only changed on one side. Alright, next, we got a lot going on here. Here's a disconformity. Those are pretty easy to see. We have a nonconformity right here, but it also has two. It's a nonconformity with an intrusion, but it's also an angular because of these broken strata right here below. We have a nonconformity right here. We also have another nonconformity right here. This nonconformity is an intrusion, and so is this one. Next, and lastly, we have this guy here. That's a disconformity. And we have this big old nonconformity right here, and that is an intrusion. If you have any questions about this tutorial, please ask me in class. This is the kind of stuff that you can expect to see on our exams.